let's talk about something absolutely incredible. It's an invisible electrical symphony that's happening inside your chest, right this second, conducting every single heartbeat with just flawless precision. I mean, really, have you ever thought about it? Your heart just beats. It keeps this perfect life-sustaining rhythm, and you don't have to do a thing. So, what's the secret? Who's conducting this internal orchestra? Well, the answer is this stunningly elegant network called the cardiac conduction system. It's basically a dedicated pathway of specialized cells that create and send electrical signals to coordinate every single beat. So let's trace that path, starting right from the very first spark. Yeah, our whole story begins with a single tiny spark. This is the origin point of every beat you've ever had in your entire life. Okay, so meet our main character, the sinoatrial node, or the SA node for short. It's tucked away in the heart's upper right chamber, and this microscopic little cluster has a monumental job. You see, unlike regular muscle cells, these cells have what's called automaticity, which is just a fancy way of saying they have the incredible ability to generate their own electrical charge. This is what makes them the starting point for everything. And because of that automaticity, the SA node is, for all intents and purposes, the heart's natural pacemaker. It just spontaneously creates an electrical impulse, somewhere between 60 to 100 times a minute, setting the rhythm and kicking the whole process off. But once that spark is created, it can't just flood the heart all at once. That would just be chaos, right? Instead, it has to travel to a critical checkpoint, a gatekeeper that is responsible for perfect time. And that gatekeeper is the atrioventricular node, or AV node. It's so strategically located, right in the center of the heart, and it forms the only electrical bridge between the upper chambers, the atria, and the big, powerful lower chambers, the ventricles. So the AV node acts like a traffic controller for the heart's electrical signals. But here's its most important job. It catches the impulse coming from the SA node, and it deliberately holds onto it for just a fraction of a second. This tiny delay, it's absolutely crucial. So why? Why the pause? That little pause is everything. It makes sure that the top chambers, the atria, have enough time to fully contract and squeeze all the blood down into the ventricles. It's only after the ventricles are completely full that the AV node finally lets the signal go, telling them it's their turn to pump. Without that delay, the heart would be a really inefficient pump. Okay, so once the gatekeeper gives the all clear, the signal needs to get to those powerful lower chambers, the ventricles, and it needs to get there fast. For that, you need an express lane. Right after the AV node, the signal zips into